we had briefly created a bunch of interfaces and a bunch of classes. Actually, we had not. We had created a very simple. We had created a couple of interfaces, if you remember. One was the accounting interface, which had two methods: get C price and get S price, which meant the selling price and the cost price. Then we had created an interface called inventory. We were interested in the shelf life of a particular product, and we were also interested in the state of a product, which is basically a solid, liquid or gas. And then we had talked about material class, which was implementing all these interfaces and both these interfaces, and it had the public implementation of the methods in that interface. So that is where we had stopped. So what we will do is we'll open up these files in Edit Plus briefly and just go through them once. Let's go through each interface and then the class, just to recap what we did last class. So we have the interface accounting, which has two methods: get C price and get S price. Both of them return a float. We have inventory.java, which has get shelf life and get state. Shelf life is how long the material lasts in the inventory. Get state is solid, liquid, gas. And then we had a class material, which implements accounting and inventory. That means it is contractually bound to provide body for the methods for accounting interface and inventory interface. So we had some private data members there, some package data members there called S price, C price, S life and state. And then we had created a constructor for material. You already know what constructors are, which is a 4-parameter constructor, which is used to initialize the state of the material object. And then we had methods for getting C price, S price, basically we had methods for getting shelf life, methods for getting the state, all that. So we created or instantiated the state in the constructor, and later we basically did the rest of the work in each of the methods. If you recollect, we had got an error when we had not marked these methods as public, saying that in an interface all the methods are public. So though while creating an interface we don't have to say the methods as public, it is implicitly understood that the methods are public. So if you don't give the public keyword here while implementing these methods or while fulfilling the contract, basically Java gives you an error saying that you're restricting access. So that is where we are. So now what we are going to do is we are going to see how interfaces are going to be useful. And for that we are going to create a class called a test class for interfaces, and we are going to play with these classes, and then we are going to make some conclusions and then take it forward. So let's get into this thing, because we are going to do quite a bit about interfaces. So we are going to create a program called, later we'll save this as test interface, or just let's call it test. Let's just keep it simple. So we're going to create a class test, which is going to have a main. So this class is going to be an executable class, which is going to be used to test interfaces. So we have public static void main. It takes a bunch of arguments, string args, and what we do here is something interesting. Now what we do inside this main is, first we instantiate basically a class, our material class. And how do we do that? Material M is equal to new material. But remember, we don't have a 0-parameter constructor. Now we have only one constructor which takes 4 parameters. Remember this from last session. We created a material object, material class with a constructor. It takes 4 parameters. What are the 4 parameters? First the selling price, then the cost price, then the shelf life, and then the state. So selling price, cost price, shelf life and state. This is the same order in which you have to give the parameters when you are creating the material object. So let's go back to our program and create a material object. Let's say selling price is going to be 15 rupees. Let's put 15 there. If it is going to be float, we say 15.0. Otherwise, if you say it's an integer, that's fine too. So let's make it an integer for the time being. So we don't need to put a f. These values will be automatically converted to integer. And let's say the cost price, that is the cost of production, is 10 rupees. And then we say what is the shelf life. We say the shelf life is 3 days. This is measured in days, let's assume. And let's say this material is liquid. So we put in liquid there. Okay. So we have created a material with a selling price of 15 rupees, 10 rupees is the cost price, 3 days is the delay, and the state of the material is liquid. Now this is a material object. We have created that. Now having created it, now something interesting. Now we declare interface accounting. We have an interface accounting. Okay, so we go back to our program and use this interface. We say accounting A. Just let's say accounting A, and let's understand what really happened when you said accounting A. When you use the line accounting A, basically A got created as a reference. Does A point anywhere? No, nowhere. Now A is a pointer to an interface. Now some of my friends here will argue with this. You just said interface is like an abstract class. Interface has no body. So how can you have A which is a reference to an accounting interface? Well, you can have, and that's the power of Java, and that's how it is used. We declare A as a reference to accounting, but obviously we cannot say accounting A is equal to new accounting, because I can't say new accounting for the simple reason accounting is an interface. You cannot instantiate an interface. Interface is like a face. It doesn't have any meat. It doesn't have any implementation. So if I say accounting A is equal to new accounting, the compiler will immediately shout at me and say, hey, accounting is an interface, which means it's an abstract class, though we have not defined abstract classes yet. But some of you will remember that an interface is like an abstract class, and that's what the compiler will shout at me. So while I cannot say accounting A is equal to new accounting, I can very much say accounting A, which expresses what is A. A is a reference to an accounting interface, which in more simple terms means A can point or A can refer to any object which implements the accounting interface. Now let me repeat this. A can refer to any object whose class implements the accounting interface. Now, so can I say A is equal to M? Can I say A is equal to M? Yes, I can say A is equal to M. Reason is M is an instance of material class, or M is a reference to an instance of material class which actually implements the accounting interface. So basically when I say A is equal to M, I am using A in a kind of a polymorphic manner. I'll refer to polymorphism and come back to it little later. But see the power. A is a reference to an accounting interface. It's a reference to a face. And what is A pointing to? A material object. Now, though the material object has many capabilities, it has 4 methods: get C price, get S price, get shelf life, and get state. Through the accounting interface, I will see only that face of material which is from an accounting perspective important. Which means through the accounting interface, I will be able to only see C price and S price. I will be able to get C price and S price. I will not be able to get the rest. Let's just confirm that. What happens when let's just print out the C price and the S price of this material. So we'll say system.out.println. We'll say this, and there we'll put in A dot get C price. This will work. This is how we are invoking the method C price. Now we are able to invoke this method because we are able to A is a accounting reference. So A dot get C price is valid, and it's pointing to a material object which actually provides both the accounting interface as well as the inventory interface. So now I say system.out.println A.get C price. Now I can similarly do get S price. Let's just repeat this line and try to get S price. Okay? Yeah, this will work too. Now I will compile these programs. Let's save this program into something. Yeah, wonderful. So let's compile all of them. Now another interesting thing you might note, when I am compiling programs using the JAVAC on my PC, as you know, right now I am not using the cloud, but I am using the JAVAC on the PC. I don't need the -CP setting which you require on the cloud. The reason is the class path is already set for this JAVAC installation, which has happened on the PC. On the cloud, on the Amazon, on the Linux Amazon, the class path is not set. So whenever we compile, we have to give the -cp dot option. This is very important to remember. The -cp dot option needs to be given when you are working with the cloud, doesn't have to be given when you are working at home on your regular PC. I mean, you will work at home anyway, but if you are using a regular compiler on your PC, then you don't need to say -cp because it's already set. The class path is already set. So now we will compile all the stuff. You'll just say javac star.java, and at one shot we'll be able to compile all of them. We did that. Now let's see, we got a test.class as expected, and we are going to ask the Java virtual machine, which is sitting on my PC now, to run. So we are saying Java test. So we got expected answer 10.0 and 15.0, which is not a great surprise because C price is 10 and S price is 15. So having got this, what does it prove? That our program works fine. So let's get back to our program and analyze it a little more. So we are back to our program, which is accounting A is equal to M. This is the important line. Line 7 is the important line. Now on 7, let's get a little more ambitious and try to do, let's say, A dot get shelf life. Okay, so let's say let's just change that system.out.println to A dot get shelf life. Let's change the method to the get shelf life. Look at the way shelf life is there. We just copy paste that method. The material does have a shelf life of 3, and then we'll get also the state. Let's get the state also. We get the state. Wonderful. So now we are creating a material object as before. We have an accounting interface A is equal to M is perfectly valid. But you see, line 8 and line 9 are going to give me a problem because the Java compiler is going to crypt and say, hey, you know what? While material is a object, I agree, which has all these methods, you're accessing all of that using A, and A is a accounting interface reference. Through an accounting interface reference, I'll show you only that phase of material as known to accounting, which is get C price and get S price. The rest of the phase, if you want to see my inventory phase of the material, you need to use an inventory reference, not a accounting reference. You're coming using A, which is an accounting reference, and using A you can only see the accounting phase, and the accounting phase does not include get shelf life and get state, so I'm not going to show you that. So those are the errors you'll expect when I try to compile this test program. So let's just go ahead and compile this. As expected, the two methods, get shelf life and get state, both of these methods have errors. The reason they are getting errors is basically because it's saying cannot find symbol. There's no symbol called get shelf life available on A. A is of type accounting. So it's looking at accounting interface and looking for get shelf life. It isn't finding that. Same thing is happening with get state. Now I can change this thing in a jiffy by making a small change in our program. And the small change in the program, what I should do is, instead of making A an accounting interface, a reference to an accounting interface, what I should be doing, I should be converting it into a reference to an inventory interface. So let's just change just one line there. So we'll make it an inventory interface. A now is a different face pointer or a face reference. It's an inventory face reference. Now you'll see we are not changing anything else. We're still creating the material object M. We are now creating A as an inventory reference. So through A we can see which phase of material. We can see only the inventory phase of material, and then we are saying A dot get shelf life, A dot get state, and this will work perfectly fine and we'll get appropriate answers. So we are going to just do the compilation all over again, and it compiles as expected and it will run as expected. Okay, so we are getting 3 and liquid. And now you understand that through an interface reference we can only get that face of the class which is as per the interface reference. So if you are looking through accounting, you'll get only the accounting interface reference. If you're looking through inventory, you'll get only access to the inventory methods. This is important to remember as far as interfaces are concerned. So now let's work a little more with our programs and move on to a interesting concept related to interfaces. Let's create a slightly awkward interface, and then let's work on this. So let's go back to accounting interface. Let's go back to accounting interface, and let's say that we are going to create a method here also called get shelf life. Okay, I think it's int. Int. Okay, we have a method int. Now this is interesting. Now there is an accounting interface which also has, besides its get C price, get S price, it has get int get shelf life. It has a method called get shelf life. So there is a method which is common between an accounting interface and inventory interface. There are the methods which are common. Now if it is like this, where the signature of both the methods are same, there are common methods, but the signature of both the methods are same in terms of their return type. The return type of both the methods is same, then there shouldn't be any problem whatsoever in order to create this program. Let's just do it let's just compile test. So what has happened now is the inventory interface as well as the accounting interface give shelf life. Okay, so let's compile this program just to try this out and see whether these things work. See the change we have made. We have moved we have now accounting interface consists of 3 methods: get C price, get S price, and get shelf life. Your inventory interface consists of get shelf life and get state. So let's just see whether this works prima facie. Now the answer won't change here because here we are going through the inventory interface. Okay, so let's just run it. Answer won't change here. Now let's change the program a little bit. Okay, now let's say, because the accounting interface also has shelf life, let's say accounting, we added that method, and of course line number 9 won't work, so let's comment it out a bit. So this will work. Now through A I can get shelf life, I can get C price, because the method is common. The same method is occurring. There's no problem with this. Let's just run it once and then I'll tell you when the problem comes. Now there won't be any problem. No problem, we run it. Yeah, so we get 3, which is shelf life, no problem. Let's go back to the program. Okay, let's go back to the interfaces. Okay, so now let's go back to accounting interface. Why there was no problem? Because there are 2 methods, and let me put it like this. There is an accounting interface, there is a this is accounting, this is inventory. Now it had common methods here. The common method was get shelf life, and there was get shelf life. These were the common methods. Both were returning an int, both had exactly the same signature. And then when I had a class which was implementing both these interfaces, which was material, which is actually shown with a dotted line. We can show it as a dotted line. I mean, that's UML for you, but it's not important to get that. So material class, which is implementing this interface as well as this interface, as long as the signature was same, we had a public int get shelf life implemented over here, and that implementation sufficed to fulfill this contract as well as this contract. Absolutely no problem. But suppose the contracts are a little different, meaning here we have a get shelf life which returns a float in the accounting interface, then obviously this will satisfy this contract, but this will not satisfy this contract, and then we will get an error. And then I will come to an important aspect of Java where we'll understand what the problem is. So let's deal with this problem. Let's first have the problem. So what we are doing is, in the accounting interface we do have a get shelf life, but we are changing it to float. That means the return type of the get shelf life over in the accounting interface is float, and in inventory interface it is int. So we go back to so it is int here in inventory interface, it is float here in accounting interface, and I have a class material which is trying to implement both. Let's look at material again. Okay, so the material is implementing all that. Okay, now let's see whether we get a problem just now. Okay, let's compile now test. And understand what's going on. Java start or Java. Yeah, you get a trouble in the class material itself because what's happening is you say class material, but it is saying now there's an incompatible type. What it is finding is, as it said, int get shelf life it is finding. It is saying this int get shelf life is fulfilling this contract. This is its way of saying this, but what you need to understand from here is the material class has an int get shelf life, that is get shelf life with an integer data type return, which is fulfilling this contract of the inventory interface. But the accounting interface contract, which is supposed to return a float, is not getting fulfilled. Now the obvious temptation for a programmer will be, oh, is that the problem? Why don't I go and add a float get shelf life? You know, a natural temptation of the programmer is that, oh, this guy fulfills this, what I'm going to do is I'm going to add a public float get shelf life with some body which will fulfill this. So a simplistic programmer will say, I have get shelf life will fulfills this, which because it has an int data type return. I have a float get shelf life because it has a float return which fulfills this contract, because get shelf life is occurring in both accounting interface as well as inventory interface. Now you'll realize, while this is may make some logical sense to some people, it doesn't work in Java, because in Java you are allowed method overloading, but not when the variation is only in the return type. So here if you observe this method and this method, the variation between these two methods is only in the return type. So if the variation of a method is in return type, this is not classified as overloading. This is very important to understand, because a lot of people think about Java is it can be overloaded, or there can be two methods with exactly the same signature but different in return types. That is not permitted. So this float and this int are going to collide, and they are not going to permit this float and this int to go together. In one class there can be only one int, there can be one method with a particular signature which can have only one kind of return type. So if the return type is int, it needs to be int. It can't be float unless you change the parameters here, because here there are no parameters, here also no parameters. The change is only with respect to int and float. That is not permitted. That means if two methods vary from each other only in their return type, such two methods will not be permitted in Java. So let's get this error properly once again. So what we are going to do here is that we are going to go to material class and try to add this kind of thing, which is we are just going to add another public float same method from line 21 to 24 he is going to copy and just change the return type to float. And why is he doing it? Because he thinks that the first method will fulfill the inventory contract and the second method, which is on line 25, will fulfill the accounting contract. But it's not going to happen because you are going into a Java problem here, a language problem here, where two methods, if you see line 21 and line 25, the two methods, their only variation is in return type. That is not permitted in Java. So let's get this clear, and let's try to compile again test, and we'll get a different kind of error, JAVAC. We'll get it at material class level itself. Yeah, that is what. So now he's saying get shelf life is already defined in material. That is, error is coming on line 25. He's saying get shelf life is already defined, which means he's not able to differentiate between this and this as two different methods because their variation is only in return type. So two methods in Java in the same class cannot vary in return type. And this is an important thing to remember. So your next question will be, if such a situation arises where you have two interfaces and both the interfaces have the same method but the return type is different, same signature method here and here, how the class will be able to implement it? The answer is simple. The class will not be able to implement such a scenario. So that's in short the answer. So don't have two methods. If you have, there's no problem, this interface having the same method, but then the difference in the method should not be only in the return type as it is happening here. So that is not permitted. Rest of it is fine. Okay, so this is an important idea to keep in mind, and let's move on to understanding a little bit more about interfaces. So we have a class material which implements these two interfaces, accounting and inventory. Let's ponder a little bit more, and let's make a few more variations of both the classes and of the material class, and understand what it means. Okay, now let's say what happens is that, let's understand the error now. Let's go back to material class. Yeah, we are in the material class. Let's come down and let's get rid of the error first, the line 25, so that we don't have that problem. Let's just delete that method, and we will also bring back our accounting interface to something more sensible. So let's either remove the get shelf life altogether or change its return type to int. So we have changed the return type to int. So this is fine now. Now the class will compile. But now what we are going to do is we are going to do something interesting. Now I'm going to comment out get state itself. I'm going to comment out get state. I'm not going to remove it. No. Comment out the whole method, get state. So now what's happening? Now if you will, I have two interfaces, as you know, accounting and inventory. Okay, inventory has two methods, get shelf life and get state, and there is material which is supposed to implement both. So now what material class has done is it has violated the contract. There are three methods here, as you know, get C price, get S price, and get shelf life. There are these three methods here. Three methods here, two methods here. This get state or whatever, which is solid, liquid, gas. Now the class material has undertaken to implement this interface as well as this interface. But what it has done, while it has body for all the methods in this interface, and of course get shelf life, as you can just see what we did in material.java in a moment, we actually have commented out the get state, meaning the class material has violated a contract that it was supposed to implement all the methods of this and this interface, but it has not done that. It has implemented all the methods of this, and it has implemented only one method of this. Now the Java compiler does not spare material class. He says, Mr. Material class, you have violated your contract, so you can call yourself abstract if you want, but since you have not called yourself abstract, I will not allow you to compile. So we are going to get a compilation error for material class again. Again we are compiling all of them. Yeah. So it's giving a very simple error. He's saying material is not abstract and does not override get state in inventory. Now we'll understand that later. But at that thing, just understand that he's pointing out you're supposed to implement accounting interface and inventory interface in toto. You have not implemented those interfaces, and that's why I need to make material class abstract. You need to make the material class, you need to declare the material class as abstract because it's violating this contract. An abstract class can violate because abstract class is an incomplete class. Another way of looking at abstract class is like an incomplete class. So if you are ready to mark material as incomplete, that is fine. You can say I will implement accounting interface, but I will not implement completely the inventory interface. Then you have to mark yourself as abstract. Well, if you mark class material as abstract, material will compile, but when you try to instantiate an abstract class, it won't instantiate. So we'll get into those problems a little later. We are still on the interfaces. So what the point I'm trying to make here is, and this is something you should remember, is when a class undertakes to implement this interface and this interface, it must implement all the methods of that interface. It must provide directly or indirectly bodies for all the methods in that interface, which it has not done here, and that's why there is a cry from the Java compiler that you need to do something to this class. Make it abstract or provide the body for this method. Okay, so let's restore it to its normal state, and let's understand a few more things about interfaces. Okay, so let's go back to the accounting interface just to add a little more things there. So let's put a variable there. Can technically, if you talk about classic UML, you talk about classic design of object-oriented languages, actually interfaces are not expected to have basically variables. However, we are violating it, and we are just saying int I equal to 10. Okay, now how do we use this I in accounting, in material? Let's see whether we can use this, we'll use it in test. Okay, so we have an accounting interface which has basically a variable called I, and that variable I want to manipulate. There is a variable called I which I want to manipulate. So I say a.I is equal to 15. Now please understand what I am doing. I am using an interface also as a repository of some variables. Actually, you will soon understand the difference of the word variable. I'll go back to accounting interface to emphasize what I have done. I have introduced a I in interface accounting, which is marked as 10, which is equal to 10, which is an integer. And then in my test program, I am accessing a.I equal to 15. Let's just see what's happening here. Okay, let's just print. Let's just print a.I. No. First let's assign it, and then let's print it. I want to show you some of the properties of this I so that you get a grip of what this I actually means. A.I. Yeah. Now you get a very interesting thing. A.I is equal to 15. There's an error which is coming. Cannot assign a value to final variable I, which means that all the variables in in A are by automatically declared as final. In Java, the keyword final is similar to the keyword const in C++, which makes a variable constant. Okay, let's go back to our interface and I'll shed more light on that. So let's focus on the accounting interface a little more. Okay, so please remember, now I'm going to tell you something interesting about this variable I. First of all, it is not a variable, it is a final. When you mark something as final, you can do it in two ways. You can say final int I equal to 10. Now you will say, I never use the word final. Well, this is something which happens behind the scene for an interface. Just like you didn't mark the method getCprice as public, but it became public. Similarly, any variable which is marked which is created in an interface, let's just understand, is a final variable. That means it's not a variable, it is a constant. So this word final is inserted silently by the Java compiler whenever it sees an I in an interface. Whenever it sees a variable declared in an interface, it automatically makes it default final. Very nice. So it makes it default final. So basically I is always final. If you put in any other variable, it also is final. This is very important to remember, that any variable created in an accounting interface, in any interface, automatically becomes final. That is one part. Okay, so that's why when you try to change it, you are able to access it, but you are not able to change it. That is, when you try to say a.I equal to 15, he's giving an error. On the other hand, if I had dropped a.I equal to 15, okay, if I had commented out, I wouldn't have had any problem in my program. It would have worked just fine, as you can see. Yeah, and we run test, I would have got the value, which is 10. Okay, so the first value is the answer to this. The second value is, of course, the get shelf life. So I got the answer I equal to 10. Now, there's another interesting thing about I. Okay, the other interesting part of this I, let's go to accounting interface, is it is public by default. If it was not public, how can a class test, which is external to the interface accounting, or for that matter anything, it is accessible. So it means it is public. So we have, though we didn't say it, just like the methods of an interface are public, all the variables which are declared in an interface, they are also public. So we have already got two parts, two kinds of attributes of I. One is, it is by default public. Also, it is final. It is accessible. At the same time, it is final. It is accessible but cannot be changed. You can only read its value. The other interesting point is, it is also a static variable. Now I know I have not yet discussed static variables. We'll be doing that soon in another couple of sessions. But static variables are those which can be accessed at the class level itself. Now we have, okay, let me put it this way. That means we don't need we don't need a reference. We can access it directly at the class. Let's go back to our program to illustrate this. Let's see whether what I am saying is true. So I said a.I is equal to 15. Now if it is accessible at the class level itself and not through a reference, I should change this to accounting.I. Now I am not using a. I don't need a reference to get to I. It is just enough if I use the class of the interface, which is accounting. Now there is a lot of difference. A is a reference to an interface. Accounting is just the name of the interface. It's the class of the interface. So I am just saying accounting.I. I am not even saying a.I. Let's see whether this is acceptable to our compiler. Yeah, it is. And when we run it, we'll get actually the same value. Yeah, same value. So what do we mean by this? Let's go back. Okay, no, not this, the other one. Okay, so it means, as he's adding properties, it means it's time to add a third property to this int I. We said I is first of all final. Second, we said I is also public, it is accessible, and it is static. I is also static. What is the advantage of a static variable, or what is the property of a static variable? You don't need a reference to access a static variable. You can access it using the name of the class itself. So here I just say accounting.I, I am able to access it. This variable, that means by default, is final. That means it's constant, it cannot change. We demonstrated that. Public, that's obvious. Though I didn't mark the word public, it was accessible, just like any of its methods. And static, it can be accessed through reference also, but it can also be accessed through a class. We will talk more about static variables, but one of the things I have said is for static variables, you can say accounting.I and you can access it. That means you're accessing it through a class, not through a reference to that class. That is how we understood the properties of variables inside an interface. So we have done quite a lot of thinking about this interface. We have said interface accounting is I is equal to 10, float C price. We have talked a lot about this I. We have understood that though we don't say it explicitly, implicitly it is public, implicitly it is static, and implicitly it is final. This is some of the things which people don't remember. So there is yet another use of an interface, which is like a repository of constants. Those of you who know C, we use hash defines there. What are hash defines? They are also constant, they are also accessible, and they are also openly accessible. So this idea is common. So we'll stop here.